Hi, and welcome to this Dear Taylor video. I'm Jessica Ma from the University of Texas at Austin. Today you're watching part 4 of a 5-part series on factoring quadratic expressions, and this video specifically talks about how to help students use a box method, which is a graphic organizer, to help students transition from the concrete and pictorial representations to moving to the more abstract representation. Before we get started, let's talk about the terms concrete, pictorial, and abstract. These terms are the 3 primary types of representations that we want to encourage all students to develop proficiency in so that they can approach mathematics problems more flexibly and comfortably. This is especially important for students with mathematics difficulty or disabilities because we want to equip these students with a range of tools that they can use to approach any math problem. So one way to help students transition from the concrete or pictorial representation to abstract representation when factoring quadratic expressions is to teach students how to use the box method. This is a graphic organizer like this one shown right here, and then we're going to look at how to use it. So before we get started with the problem, we should know 2 things. First is that at this point, you will probably present this problem to students who have already discovered the rule for factoring quadratic expressions, which broadly states that the constant term in the factor form sum to the linear term's coefficient, and then when multiplied, the product is going to be the constant term. If students understand that rule, then they can probably approach this problem in a more flexible way. Now, the second thing is that this problem is a little bit more complex because of the negative terms right here. So students should definitely try and approach this problem to try to solve it. However, do expect that students might run into some challenges, especially if they're used to solving or factoring using only positive terms. This example comes from an article by Tricia Strickland, in which she encourages teachers to introduce the box method right here, but to have the quadratic term and the constant term already put in place, so that students are just left to reason which factors of the constant term, negative 24, will have a sum of that coefficient of negative 2. Now let's get started. So first, you want to have the students attend to the quadratic term of x squared right here. Start by asking students, what are the factor pairs of x squared? Or in other words, what term multiplied by another term will give us the product of x squared? So the factor pair of x squared is x and x. I'm going to write it right here in our box where we have x times x equals x squared. Next, we can focus on negative 24. So next, we're going to ask the same question, what are the factor pairs of negative 24? So here I'm going to list out all of the factor pairs, and I'm going to determine which factor pair will have the sum of negative 2 in our linear coefficient. So let me write out all the factor pairs, which is 1, negative 24, negative 1, 24, 2, and negative 12. That's a negative 12. And negative 2, 12, keep going, 3 and negative 8, negative 3, 8, and finally 4, negative 6, and negative 4, and positive 6. So these are all of our factor pairs for negative 24, which means that all of these pairs will multiply to get the product of negative 24. And now the next step is to look at which of these pairs will have the sum, if I were to combine the 2 numbers, the sum of negative 2. I'm going to go through them and then to see which one will will match. So look at 1 and negative 24. That is going to be negative 23, which is not going to be negative 2. You can cross it out. We have negative 1 and 24, which is going to be positive 23. 2 and negative 12. The sum will be negative 10, which is also doesn't match. And negative 2 and 12 will be positive 10. Here we have the sum of negative 5, sum of positive 5. Now look, we have 4 plus negative 6, which is negative 2. But just one more to check. I'm going to check the last one. We have negative 4 plus 6, which is positive 2. So we're looking at negative 2. So this would not match. And our factor pair, that is going to give us a product of negative 24, and the sum of negative 2 is going to be positive 4 and negative 6, and I'm going to write them right here. So positive 4 and negative 6. So now we have all of these filled out. I can fill in the rest. So we can just kind of go through each of these and check again. We have x times x, which is x squared. And the next box right here, x times 4 is going to be 4x. And we have x times -6, which is -6x. And then we have the final constant, which is 4 times -6 gives us 24, or -24. So all of this is true, and I can now say that the factor form of 2x minus, x squared minus 2x minus 24 is x plus 4 times x minus 6. That's going to be our factor form. Thank you for watching this Dare Tailored. Make sure to check out the last video in the series in which we encourage students to look at the equivalency between quadratic expression and its factor form.